In this video, we're going to look at some exam questions that use complex numbers that come out of IEB November exams. The first one we're going to look at comes out of the IEB exam 2012, and it asks us to determine the value of k if x is equal to 2 plus 3i is a root of that equation. Now, the first thing we need to remember is if 2 plus 3i is a root of the given equation, then the complex conjugate, 2 minus 3i, will be another root. The next thing we need to think about is if we have a cubic equation, it will be factorized into a binomial and a trinomial. And we're going to look at the trinomial first. But before we try and figure out the trinomial in this equation, what I want to do is take you back to real numbers. And let's just have a look at a trinomial based on real numbers. Well, if x is equal to 3 and x is equal to 2, those are two roots of any given equation. A possible equation would be x minus 3 times x minus 2 is equal to 0. In other words, where x squared minus 5x plus 6 is equal to 0. Let's try and work slightly differently. Instead of getting our brackets and multiplying out, let's see if we can't get the values of b and c in a slightly different way. Well, first of all, if we have a look at 3 and 2, if I multiply them together, I will get 6. So I can get the c value by going 3 times 2. And then if I go 3 plus 2, I will get 5, but I need minus 5. So all I'm going to do is change the sign. So if I add them, but I change the sign, I will end up with minus 5. And we're going to try and use a similar technique to calculate b and c of a complex equation. So let's look at this one. If I want the value of c, I'm going to multiply the two roots together. In other words, 2 plus 3i times 2 minus 3i. And if we FOIL that, we end up with 4 minus 9i squared. Now remember, I squared is just minus 1. So replace I squared with minus 1, and I end up with 4 plus 9, which is 13. And to get the value of b, the easiest way to do it is to add those two roots together and change their sign. So 2 plus 3i plus 2 minus 3i. 2 plus 2 is 4, and the 3 and the minus 3i will cancel each other out. So I end up with b is equal to minus 4, which means that my cubic equation x cubed minus 5x squared plus kx minus 13 can be factorized into a binomial and the trinomial that has x squared minus 4x plus 13. So before I can figure out k, I need to figure out how to complete that binomial. And the easiest way to do it is to decide p times 13 must give me minus 13. So what times 13 can give me minus 13? Well, minus 1. So the only value I can substitute into that binomial is minus 1. Now, if I want to know the value of k, we can multiply out those brackets. But because I only need the value of k, I'm not going to go to a lot of extra work because it'll waste time. And we know in our IEB exam, in the further studies exam, we don't have time. So we're going to just take a shortcut. And if all I'm interested in is the coefficient of x, I'm just going to look at the x's. So x minus 1 times minus 4x and x times 13. Those are the only ones that will end up giving me a coefficient of x. So minus 1 times minus 4x is positive 4x, and x times 13 is 13x. So 4x plus 13x is 17x. In other words, the value of k is 17. This example comes out of the IEB paper from 2015, and it's very similar to the previous question. This time, though, we just have two values that we need to calculate. So first of all, we need to remember that because 3 minus 7i is a root of the given equation, we can assume that 3 plus 7i is another root of the equation. And secondly, if we factorize the cubic equation, we will have a binomial multiplied by a trinomial. The only difference is the coefficient of x cubed is 2, So it's quite safe to assume that the coefficient of x will be 2 as well. So next I want to calculate the coefficients or the values of b and c. Now c we can calculate by multiplying those two complex numbers together. So we end up with 9 minus 49i squared. And remember, I squared is just negative 1. So 9 plus 49 is going to give me 58. To calculate the value of b, we're going to add those two complex numbers together, but change the sign in front. So 3 minus 7i plus 3 plus 7i, I will end up with minus 6. So if I factorize my cubic equation, I will have a binomial and multiplied by x squared minus 6x plus 58. Now we still need to figure out the value of k. And the easiest way to do that is to ask yourself, k multiplied by 58 needs to give you minus 58. So what times 58 gives you minus 58? Well, minus 1. In other words, the cubic equation is 2x minus 1 times x squared minus 6x plus 58. Now in this question, we need to figure out the coefficient of x squared and the coefficient of x. So because we need both of those, it's just easier to multiply the binomial by the trinomial. So we're going to take 2x and multiply it by each term in the trinomial, and we end up with 2x cubed minus 12x squared plus 116x. And then we'll do the same with a minus 1 to each term in the trinomial. And we end up with minus x squared plus 6x minus 58. And if we add and subtract like terms, we end up with 2x cubed minus 13x squared plus 122 minus 58, which means that our p-value in this equation is minus 13, and the q-value is 122. This question comes out of the IB paper of 2021, and it's slightly different to the previous two questions that we've been looking at. So we need to consider the equation f of x is equal to x to the power of 4 minus 3x cubed minus 5x squared plus 29x minus 30. And we're told that if 2 minus I is a root of f of x, we need to write f of x as a product of two trinomials. First thing we need to remember that if 2 minus I is a root of the given equation, then 2 plus I will be another root. In other words, my equation, that is x to the power of 4, can be rewritten as two trinomials. First of all, we're going to have a look at the value of c, as we did in the previous two examples. And we can get the value of c by multiplying those two complex numbers together. And we end up with 4 minus I squared. I squared is just minus 1, so 4 plus 1 is 5. Then the value of b, the coefficient of x in that first trinomial, I'm just going to add my two complex numbers together and change the sign in front. So we end up with minus 4. So my equation can be rewritten as x squared minus 4x plus 5 multiplied by another trinomial. And we need to figure out the values in that next trinomial. And we're going to use a similar method to the other two examples. To find the value of q, we're going to ask ourselves, 5 times q needs to give me minus 30. So 5 times what will give me minus 30? 5 times minus 6. So q is relatively easy to calculate because 5 times minus 6 will give me minus 30. Then we need to calculate the value of p. And to do that, we're just going to use, you can choose. I'm going to use minus 3x cubed, but you can choose one of the others if you prefer. I'm going to choose minus 3x cubed because the only way to get x cubed is by going x squared and x. So it just limits the calculations I have to do. So first of all, x squared times px is the one that I'm going to use, and that will give me px cubed. And then the other combination that will give me x cubed will be the minus 4x times x squared. And minus 4x times x squared is minus 4x cubed. So if we add those two together, px cubed minus 4x cubed, we need to end up with minus 3x cubed in the original equation. If you simplify that, I can take 4 over to the other side, and I end up with px cubed is equal to x cubed. In other words, the value of p, or the coefficient of x cubed, is going to be 1. The question from 2021 had a second part to the question, and it's just finishing off the question. It says, hence solve f of x is equal to 0 in complex numbers. In other words, we would need to factorize that second trinomial, because we already know that the roots of the first trinomial are 2 minus I and 2 plus I. It's just the roots of the second trinomial that we need. So if we factorize that second trinomial, make my equation equal to 0, I end up with x plus 3 and x minus 2 as factors. And then just to simplify that further, we already know that the roots of x squared minus 4x plus 5 are 2 minus I and 2 plus I. And then the last two brackets will give me solutions x equals minus 3 and x is equal to 2. The second question that came out of IB 2021 was as follows. Quandy defined a new kind of complex number called a Quandy number. It had the property that the imaginary portion of the complex number is equal to 2 times the real portion of the complex number. In other words, a Quandy number z is of the form z is equal to a plus 2ai. And we need to prove that for all Quandy numbers, z over its complex conjugate, remember the notation z star stands for its complex conjugate, can be written as minus 3 over 5 as the real portion plus 4 over 5i as the imaginary portion. Right. The best way to start this question is to first write z over z star. Now z is a plus 2ai. So z star, or the complex conjugate of it, will be a minus 2ai. Now we cannot split that denominator or split that fraction in any way. So our only option really is to multiply by a version of 1. And if you have a look at what we're trying to prove, we're trying to show that there are no i's in the denominator, basically. So how can we get rid of the i's in the denominator? Well, we want to choose the correct version of 1 to multiply by. And to get rid of the i's in the denominator, I would want to create the difference of 2 squares. So I'm going to choose to multiply by a plus 2ai over a plus 2ai. If I multiply top with top and bottom with bottom, on the top we're going to end up with a squared plus 4a squared I plus 4a squared I squared. And on the bottom, we're going to end up with a squared minus 4a squared I squared. Now we can simplify this a little bit further because we know that I squared is negative 1. So if I replace I squared with negative 1 in the numerator, we end up with minus 4a squared as a final term. And if I do the same in the denominator, I end up with plus 4a squared as the final term. And if we simplify further, we will end up with minus 3a squared plus 4a squared I in the numerator and 5a squared in the denominator. This fraction I can now split. I can give the 5a squared to the minus 3a squared and to the 4a squared I. And in both cases, the a squareds will cancel, and we're left with minus 3 over 5 plus 4 over 5i, which is exactly what they wanted me to prove. Thanks for watching Max Maths. If you liked what you saw, please like, share, and subscribe.